let's start the class. Today our topic of discussion is learning rule, right? So here there is one important point. As we have started earlier, means whatever discussion we have done previously, I have already stated that ANN is completely inspired by the way biological nervous system will work. That is, it will follow the mechanism of human brain. Now, the most impressive characteristics of human brain is that it can learn. So here, what is our topic of discussion? Today we will identify the exact algorithm, or today we will learn the algorithm by which we will understand how a particular neural network can train itself, or you can say that how it can learn. So if I ask you this question, that what is the meaning of learning? So basically, learning means to adapt something, or you can say that to adapt some changes. Whenever environment is changing, if we can adapt that change and we can learn something from it, it is the process of learning. So learning means to do and adapt the change in itself and when the environment is changing. This is the concept. So ANN is a very complex system, or more precisely, we can say that it is a complex adaptive system. You have to pay attention in this point. That is, we are talking about adaptive system. Basically, ANN can change its internal structure based on the information that we are passing through it. So this is known as adaptation. Now you can ask me one question. Okay, we have understood everything, that we are going to discuss about a topic, that how neural network will work. Now here we will learn today Hebbian learning rule, but we will have many kinds of learning rule. So we do not have a single learning rule that a neural network will follow. So we have so many kinds of learning rule. The first kind of learning rule is known as Hebbian learning rule. And the second kind of very popular learning rule is known as perceptron learning rule. And we have delta learning rule. And nowadays we are talking about other two learning rules. One is known as correlation learning rule and another one is known as outstar learning rule. So today we will focus on this first learning mechanism, which is known as Hebbian learning rule. Sometimes it is also known as Hebb's learning rule. Now here we have to understand the basic concept, means why we are learning this particular rule and what is the basic feature of this learning rule. See, whenever we are talking about a learning rule, the first question that should come in your mind, where should we apply this learning rule? This is the important question. Means we know that the architecture of the neural network, but whenever we are applying the learning rule, what it is actually doing. So I can explain it in an elaborate manner, but I will tell you one point, that is, I will discuss about the basic outline of this two learning rule. First, if anybody asks you this question, why Hebbian learning rule? You can tell them that it identifies how to modify the weights of the nodes. So I am using Hebbian learning rule in order to adjust the weights, right? So the mechanism that we will learn, it will be applied on the weights. So this is the concept of Hebbian learning rule. On the other hand, what is the perceptron learning rule? See, in perceptron learning rule, the network starts its learning by assigning a random value to each and every weight. So what is the conclusion up to this? So whenever we are talking about any learning rule that is applied on any certain neural network, this learning rule is meant for adjusting the weights. So we will use some specific formula in order to follow the Hebbian learning rule, and that formula will help us to calculate the weights of the neural network. On the other hand, if I use perceptron learning rule, what it will do, it will assign random values to the weight. Means it will not use any kind of formula in order to update the weights. So this is the basic concept of this two learning rule. Now you can ask me this question, okay, then tell me what is the basic concept of delta learning rule. See, here in the delta learning rule, the modification in the synaptic weight, means whatever weight we are talking about, of a certain node is equal to the multiplication of error and the input. So there is one error factor in the neural network. How it occurs, I will tell you. So whatever may be the scenario, just remember one point. Whenever we are computing synaptic weight using delta learning rule, there will be two factors that we have to take into consideration. That is error factor and the input value of the neural network. So basically my point is, whenever we are talking about different learning mechanism, our aim is to understand how these weights of the neural network will be calculated. This is our objective. So now today we are going to discuss Hebbian learning rule, right? So I am not going to discuss the algorithm. I will show each and every step how this Hebbian learning rule will work. And what is this input is all about? Now I am going to explain. So via this input, I am going to discuss the Hebbian learning rule. So this is the input, or you can say that this is the problem. And today we have to implement the Hebbian learning rule in order to solve this problem. And what is this input is all about? It is an implementation of AND gate. And I will explain this input one by one. Now the first point. See, whenever a problem is given to you and you are asked to apply the learning rule, what we have to identify. So first thing, you have to identify how many training samples we should consider. So what is the number of training sample? First you have to identify this thing. So what do you mean by training samples? See here how many inputs are there. Here we have 4 inputs. So basically we will have 4 training samples. So whenever a problem is given to you, try to identify the training samples first. And it is dependent on the number of inputs given in the problem. But the next question is why we are concerned about these training samples? Because on this training samples, the iterations means how many times this algorithm will iterate, it depends. So since we have 4 training samples, we can easily state that there will be 4 iterations. So from this problem statement, we have identified the number of training samples, which is equal to the number of iterations. So this algorithm will iterate 4 times. So this is the first consideration. Now, in the previous class, I have talked about some activation function. So each and every neural network will work on some activation function. So details of the activation function and types of the activation function, I will explain it later on. But try to understand, whenever a problem is given to you, definitely in that problem, the type of the activation function will be also provided. So in this problem, the type of the activation function is written as bipolar sigmoidal activation function. It is given that means if we are going to implement this problem by using some neural network, which activation function we should use? They have mentioned that we have to use bipolar sigmoidal activation function. But now immediately you will ask me this question, that why it is mentioned. See, mathematically, whenever the name of the activation function is given to you, you can find out the value range that this activation function will consider. So basically my point is, bipolar sigmoidal activation function will take the range between -1 to 1. So whenever we are using this activation function, the value range will be between -1 to 1. So in the previous class I have explained that for depending on any particular problem, the type of the activation function will vary. Sometimes we have to determine the activation function, sometimes it is given. So since if you perceive this problem, if you see this problem, see each and every value is between 1 and -1. So depending on this problem, they have already given that bipolar sigmoidal activation function is fit for it. So try to understand the conclusion. If this problem is given to you and no activation function is mentioned, from the experience you will find that since maximum of the values are between -1 and 1, so it is better to use this bipolar sigmoidal activation function. So this is the second conclusion that we can draw from this input, right? So please make a note, just write it down. That is, whenever any problem is given to you, then identify training samples in order to find the number of iterations, and then try to find out the activation function if it is not given. And the type of the activation function will be determined by visualizing the values given in the problem statement. So this is the first part. Now come to the next part. That is how this Hebbian learning rule will work. So this is our problem, right? So let's start. So if you ask me this question, that how this Hebbian learning rule will work, I will tell you one point. So since we are talking about a learning rule, means how this synaptic weights are adjusted. This formulation is given by this learning rule. So basically, if I want to compute any new weight of the neural network according to the Hebbian learning rule, we have to consider the old weight, means the previous weight, plus input, and according to that we have to consider the output. So it will be treated as, if I want to find out wi, means new set of weights, then we have to consider old set of weights and set of inputs and outputs. Additionally, you have to remember one point, not only updating the weights, also we have to update the bias. So according to the Hebbian learning rule, if you want to update the new bias value, the formulation will be same. We have to consider the old bias value and then we have to consider the output. So this is the basic consideration. But how to apply this formula in a stepwise manner in order to solve this problem using artificial neural network, it is important. So whenever you are using Hebbian learning rule, the first thing you have to remember, you cannot use this formula straight away in the first attempt. So first what you have to do, first you have to set the synaptic weights, or first you have to set all the weights to 0. So this is the first step of the Hebbian rule, that is, if you have wi number of weights in the neural network, all of the weights will be set as 0. And here, what is the value of I, the iteration? It depends on the training samples. So here I'm just writing this I will vary from 1 to say n. And also you have to set the initial bias value to 0. So you have to remember one point when I have explained a basic neural network in the previous day's class. I have set the bias value to 1 and I have stated that bias value is a constant thing that you can set any value. So at that point of time, I have arbitrarily taken the bias value as 1. But whenever you are using Hebbian learning rule, this is fixed. So whenever you are starting this algorithm, all weights should be initialized to 0 and bias value should be initialized to 0. So this is the first point of this algorithm. Now, since we are talking about any algorithm, this algorithm must iterate because we have to update the weights, and updation of the weights will be performed using some amount of iteration. So this algorithm will iterate through some steps, and that iteration steps I'm going to explain. So this part I'm just leaving it as vacant. Now come to the third step. So after setting all weights and biases to 0, then we have to set what? Then we have to set the activations. Activations for what? Activation for input units, say with the input vector xi is equal to si, and this I will iterate to 1 to n. Now see, whenever I am explaining this line, some of the parts are not understood. Why it happens? Because I haven't used the example. So this point will be clear to you when I will explain it in terms of this problem. So anyways, the third point is we have to set the activations. And the fourth step is we have to set the corresponding output values to the output neuron. That is, say for an example, y is equal to t. So again this step is not clear. So we need to explain one example, and in the fifth part we have to update the weights. So how this updation of weights will be performed? Using this equation. And in the step number 2, what we have to do? In the step number 2, we have to repeat this process up to this, means up to step 3 to 5 we have to repeat this process. So this is the very basic steps of this algorithm, but this is very hard to understand. So let's start with the example. So if we solve this example, it will be very clear to you. So now let's start. So now let's talk about point number 1. See, the first thing I want to tell you that this neural network is treating everything as vector. So now see how these weights and biases will be initialized to 0. So basically in the first step we have to set weight and bias to 0. So we will write it as W is equal to, in terms of vector, so we have to set it as 0. So this is a transpose factor. And how we will assign the bias? We will assign the bias to 0. So why this kind of scenario I will tell you. Now according to the step number 2, we have to set the input vectors. Now how to set the input vectors, because this term is not clear to us. So we have to set the input vector, means we have to write it like this. See, here I am using capital X, means I am dealing with vectors, and we know the value of I. The value of I will be 1, 2, 4 because we have 4 training samples. Therefore, the iterations will be 4. Now, how it is happening? See, now this is the important part. How to set this input vector? So, we will have 4 input vectors. It is clear? So, we have 4 input vectors. And now, how I am setting this value? So, the first value. See, what is the first value of the input vector? It is -1 minus 1 and the bias value is 1. So it will be minus 1 and 1. And here we have 1 transpose. So why we have 3 values now you got? This is for x1, this is for x2 and this is for b. So I'm setting the first input vector x1 means I have to write minus 1 and 1. Now how I am setting the second input vector? It is minus 1, 1, 1. Then transpose. So similarly, I can set all the input values like this. So this is the meaning of this line. So we have to set the input values xi equal to si where I ranges from 1 to 4. Right? This is about step 2. Now let's talk about the next step. That output values must be set y is equal to t. Now what is the meaning of setting the output value? So it is the important thing. So in the neural network we will have the final output as y. Now what is this t? I will tell you. But before that let me elaborate this step a little bit with some weight updation rule. So now the most important part, that is the step 4. So how we are modifying our weights. So in order to modify the weight, we have to use this formula. W new equal to W old plus say xi yi. In the first iteration, how could I update the weight? W new is equal to W old plus the formula will be x1 and y1. So try to understand the meaning of y because we have to focus on this. How this Hebbian rule is working. See, in the first iteration, how this weight is calculated. Here we have to find out what is the W old value. So according to step number 1, initially the weight is set to 0. So for the first iteration, the old weight means the weight which is set as 0 plus what is the value of x1? So we have extracted the value of the x1 from this problem, that is minus 1 and 1. So what is the value of x1? Minus 1 and 1 transpose. And what is the value of y1? See, pay attention. Corresponding to this input, the value of the y1 is minus 1. So this is the value of y1. So I think the value of y is now clear to you. So how Hebbian rule is applied to update any weight, this is the iteration number 1. So from this iteration, if you calculate this value, then you will find 1, 1 and minus 1 transpose. So this is the first iteration. Now see how the second iteration will work. Now for the second iteration, again we have to calculate W new. So W new means W old plus this value. Now here the biggest question is, what is the W old value? See, here the W old value means just the previous value that we have encountered in the first iteration. So in the first iteration, the computed W new value is this one. So this value will be treated as the W old value in the second iteration. So this value will be treated as W old value in the second iteration. And then the formula will be x2 and this one will be y2. So what is the value of x2? Minus 1, 1 and 1. Minus 1, 1 and 1. And what is the value of y2? This is the value of y2. So I'm just writing it. So now we have to calculate the W new value in the second iteration. So if I calculate it, it will become 2 0, and this one is minus 2 transpose. Right? Now come to the third iteration. In the third iteration, again we have to compute the W new value. How could we calculate the W new value? So whatever value we have got in the previous iteration as the value of W new, it will act as W old value in the third iteration, and then we have to take this value 1 minus 1 1, 1 minus 1 1, and then the value of this y3, that is minus 1, and we can calculate this value as 2 2, and this one is minus 2 transpose, right? Sorry, I have made one mistake. It will be 1 1 and minus 3 transpose. 2 0 minus 2 and 1 minus 1 1 minus 1, yes, 1 1 minus 3 transpose. Now come to the fourth iteration. In the fourth iteration, again we have to calculate the W new. So W old means this value minus 3 transpose, and then this value 1 1 1, and then we will have the y4 value, and the y4 value here is 1, right? So here in the fourth iteration we will get 2 2 and minus 2. So we need 4 iteration because we have 4 training samples. So here how the final network will look like. So this is the output of the final neural network, and see here what is the value I am getting. Here I am getting the value of x1 as 2, it is mentioned over here. Value of x2 as 2, it is written over here, and the value of the bias here I am getting as minus 2, it is written over here, right? So this is the neural network that is depicting this particular problem. So whenever we are going to create one artificial neural network to solve AND gate problem, the final outcome of the neural network will be like this, where the updation of this artificial neural network is done through Hebbian learning rule. So this is the outcome of the Hebbian learning rule.